Now we'd like to look at the combined pathways, all the ascending and descending pathways of these major motor and sensory pathways. The next diagrams are filled out and labeled for you to see the relative positions of the three pathways at each level of the central nervous system. Note that where the pathways travel together, a lesion at that location is likely to affect more than one pathway. The purpose of this section is to show the proximity of the pathways at each level. As you might expect, damage may affect only one pathway, or two, or all three may be affected, particularly if they run together. And as we can see, the dorsal column lemniscal pathway represented here in blue, the spinothalamic pathway represented in green, and the corticospinal pathway represented in red. And we can see at various locations they're very close together, and at other places they're far apart. In the medulla, for instance, we can see that the pyramid, the corticospinal tract, is immediately adjacent to the medial lemniscus. Whereas in the pons, we see the spinothalamic tract is closer to the medial lemniscus, particularly the leg area. And as we arise up to the midbrain, we see that the medial lemniscus and the spinothalamic tract are right next to each other, so they're more likely to be affected together. We'll walk our way through various levels of the central nervous system to see where these fibers are located, where the pathways are located relative to one another. And of course, the incoming sensory fibers are right next to each other immediately in the dorsal horn, in the dorsal root, and are likely to be affected together by damage to the dorsal root. However, as soon as they enter the central nervous system, those fibers tend to separate out into different pathways in very different locations and separate out from the corticospinal tract. As we come up to the spinal medullary junction, that is in the caudal medulla, we can see that the dorsal column nuclei, site at which the primary neuron synapses coming into the caudal medulla, and at that location, those fibers, the secondary fibers, will start to cross over to the other side through the internal ocular fibers, and they start to approach the corticospinal tract, but they stay separate from the spinothalamic tract. As we move up into the medulla, into the middle medulla, we see now that the corticospinal tract, represented here in the pyramids, is immediately adjacent to the medial lemniscus, with the leg area most inferior immediately adjacent to the corticospinal tract, so they're more likely to be affected together. And recognize that this is a location where the anterior spinal artery has penetrating vessels that feed both of these areas and could easily, if they were blocked, affect both corticospinal function as well as dorsal column lemniscal function at this portion of the medial lemniscus. As we move higher up into the pons, we see that the medial lemniscus and corticospinal tract are more separated, but the medial lemniscus is starting to approach, particularly the leg area, and the foot is starting to approach the spinothalamic tract. So a lateral lesion that affects the spinothalamic tract is more likely to affect the foot area than the hand area. Penetrating vessels from the basilar artery have the possibility of affecting both the corticospinal tract here as well as the hand area of the medial lemniscus. As we go up into the caudal medulla, we see now that the medial lemniscus is immediately adjacent to the spinal thalamic tract. So they're likely to be affected together in a lateral lesion. The corticospinal tract is somewhat separate in the crus cerebri. As we go higher in the midbrain, we see again that the spinal thalamic tract and the medial lemniscus are immediately adjacent to one another and likely to be affected together and somewhat separate from the corticospinal tract in the crus cerebri. As we go up to the cortex, we see first in the thalamus, represented over here as well as over here, that we have the possibility of both pathways, both sensory pathways being affected in the thalamus. And then immediately adjacent in the internal capsule, all three pathways are at the closest location they are anywhere in the nervous system. So all three pathways can be dramatically, easily affected by lesions in the internal capsule. As the fibers leave the internal capsule going up to the cortex, they become dispersed in order to represent different parts of the body. So although they're very much congested in this area of the internal capsule, they're spread out over the cortex, where the leg is represented most medially, and the arm more laterally, and the head most laterally. And motor cortex corresponds in the precentral gyrus to what you see in the postcentral gyrus for the different parts of the body. As a result, the likelihood of corticospinal fibers for the face, or the corticobulbar fibers for the face, and sensory fibers for the face are located close together in the cortex, right across the central fissure. And similarly for the hand area is represented motor cortex and sensory cortex immediately adjacent to one another could easily affect both of those for the hand. And similarly for the leg in the paracentral gyrus, motor cortex would be readily affected for the leg, as well as sensory fibers for both pain and temperature and vibration position in the paracentral lobular posterior portion. We'd now like to look at various lesions and see how they might affect some of these structures. Which of these lesions that we're looking at produces a sensory loss? So we're looking for the dorsal column lemniscal pathway, and when we're up in the brainstem, we're looking for the medial lemniscus, as well as the spinal thalamic pathway. Recognize that the medial lemniscus is sitting right here, so A would produce a sensory loss. It would be position of vibration, particularly in the leg, which is sitting right here on the contralateral side. It would also produce a spastic paralysis on the body on the contralateral side. So A is the correct answer. Which of these would most likely result from an obstruction of the basilar artery? So we're looking for the basilar artery. It would feed the pons. We see the pons here, and we see the basilar pons, and the basilar artery would be sitting right here. So these fibers, these corticospinal fibers, are likely to be affected by an obstruction in the basilar artery, and the corticospinal fibers, and maybe or maybe not those more distant sensory fibers that we see up here in the medial lemniscus and spinal thalamic tract. So C is correct for that. Which of these lesions contains fibers from the left cortex? So we're looking for the corticospinal tract, and of course we have the corticospinal tract sitting here in the crus cerebri, and this is the left side, so that corticospinal tract from the left side would come down through the corticospinal tract through the crus cerebri at this location. So this would be correct, and that's B. Other questions. Compare and contrast a middle cerebral artery stroke with an anterior cerebral artery stroke. What are the patient's symptoms in each? Now, the middle cerebral artery covers much of the lateral portion of the hemisphere, and in that case, a stroke in that area particularly affect the hand and face area, and you'd have a spastic paralysis of the hand and face, and only of the leg to the extent that it caught the internal capsule and descending fibers, and for the corticospinal tract, and ascending fibers for the sensory pathways. So this would be the most extensive, and certainly would get the face and the hand and maybe the leg. The anterior cerebral artery, feeding the medial portion of the hemisphere, would certainly hit the has likelihood to hit the paracentral lobule and leave loss of sensory and motor function in the leg and in the foot, reflecting the topographic representation of both motor and sensory functions over the precentral and postcentral gyrus and the paracentral lobule. We'd like next to compare and contrast an anterior spinal artery stroke with a posterior spinal artery stroke. Recognize that the anterior spinal artery sitting at the midline would affect both sides in general, and that includes in this ventral portion of the spinal cord and the lateral portion of the spinal cord, the corticospinal tract that's sitting right here, and the spinal thalamic tract that's sitting right here. So you would have spastic paralysis below this level on both sides, and you'd have a loss of pain and temperature below this level on both sides. If the posterior spinal artery, there are two of them, one on this side and one on this side, and each posterior spinal artery supplies the dorsal columns on one side. So if you had a stroke of the posterior spinal artery on this side, it would affect dorsal column on this side, and you'd have a loss of vibration of position ipsilateral at and below this level. As you can see, the anterior spinal artery covers almost 2/3 of the spinal cord, its levels. And then we'd also like to look at a lesion and determine what this particular lesion affecting this portion of the spinal cord, which of course is the thoracic level of the spinal cord, what would it produce? Would it produce a contralateral Babinski? No, the corticospinal tract is sitting here, and it would produce an ipsilateral Babinski. Would it produce a partial sensory loss in the ipsilateral arm? No, this is the thoracic cord, so the arm is not represented here, would be spared. A contralateral sensory loss level. Yes, the spinal thalamic tract is sitting here, and those fibers had crossed lower than this, and as a result, there would be a loss of pain and temperature in the lower extremity on the opposite side, contralateral side. Decreased reflexes in the ipsilateral leg. No, the leg is not represented here for the lower motor neuron. Decreased reflexes is an effect of a lower motor neuron damage, and you might see that if this was a lumbar cord. Sensory loss in the ipsilateral leg. No, because the dorsal columns are spared, and the spinal thalamic tract has crossed over to this other side, from the other side. So there would not be ipsilateral findings of pain and temperature. So C is correct. If there are any questions about these, don't hesitate to give me a call, and I look forward to speaking to you. Thank you.